What is up, winning team? Hello and welcome back to our new book series. You guys know we love a good book read, especially in January. And right now we are reading, or we've just started reading, Beyond the Veil, Exploring the Bubble Theory and the Fourth Dimension. And this is a beginner's journey into higher dimensions and modern physics, written by Jamil Chamberlain. The book is going to be linked in the description box below on Amazon. Super cheap. Go grab it. And now that I'm recording chapter 1, I can confirm I have asked my friend, because her husband's book, he's the one who wrote this, for permission to make this series, and I've been given permission from the author. So that it makes this so much better, because obviously I know them, so I didn't want to I wanted to make sure, because this is a lot of work. This is a lot of work that goes into making something like this. So I wouldn't want to disrespect the hard work, by not doing the book, but apparently they're happy for me to do it. So that's so exciting. And it's just great. I would so much rather bring attention. You know how I tell you guys all the time that the powers of the people? I would so much rather be bringing attention to things that are of people who I know and who I would want us to be spending our time and energy and money on, rather than these random riffraffs of the world, right? So let's just get straight into it. And this chapter is called Life in Three Dimensions. If you guys want to know the rest, we did the introduction in a previous video. Go and check those videos out. There's going to be also a link to that in the description. So check out the other videos in the description. Go and buy the book in the description. It's all going to be there in the description. Let's get going. So chapter 1, Life in Three Dimensions. Right, so we started out, actually you're just gonna have to go and watch the last part, to be honest, to find out what we was talking about last time. If you want to know what we're talking about now, you can have to go and find out by going and looking at the last part if you want to know. Life in Three Dimensions, our everyday reality. Take a moment to look around you, whether you're sitting in a cozy living room, walking down a bustling street, or enjoying a serene park. Your experience is shaped by 3 dimensions. Length, width, and height. You guys already know that this is very much up my street. I love me a bit of mathematics. I love me a bit of maths and science. So loving it already, right? Length, width, height, X, Y, and Z, it literally just goes on to say that. Blah. Anyway, these dimensions define the space we inhabit and navigate every day. They're so fundamental to our existence that we rarely stop to consider them. They simply are. When you reach out to grab a cup of coffee, you're moving your hand through these 3 dimensions. Architects design buildings considering all 3 to create functional and aesthetically pleasing spaces. Athletes train to excel in movement within the tri-dimensional arena. Our entire physical world is built upon the fabric of these 3 dimensions. This is so good, because I feel like if you're somebody who's not done science in any way, you could really just read this, and it explains everything, I feel like, in a way that everybody could literally understand. This is the kind of book I would give to my child to read, by the way. If you guys want to know what types of books I would give my kids to read, for their development or whatever, it'll be something like this. Defining dimensions in simple terms. But what exactly is a dimension? In the simplest terms, a dimension is a direction in which you can move or measure something. Let's break it down. Length, X. This is the dimension that runs from left to right. Imagine standing on a straight road stretching out to the horizon. That's length. Width, the dimension that runs front and back. Think of the path. Think a path that crosses your road, allowing you to move forward and backward. And height, the dimension that goes up and down. I love this. This is such a good explanation. Consider climbing a flight of stairs or a bird soaring into the sky. These 3 dimensions are perpendicular to each other, which means they're at 90 degrees to each other, essentially. Meaning they all... I'm going to stop talking meaning they all intersect at right angles. Together, they form the coordinate system that maps our physical space dimensions. Oh, this is going to be so good! Oh, I know this is going to be good. Okay, Flatland, a world of 2 dimensions. To understand dimensions better, let's embark on a thought experiment inspired by Edwin A. Abbott's classic novella, Flatland. Imagine a world that exists in only 2 dimensions, a flat plane with only length and width like a sheet of paper. The inhabitants of this world, let's call them Flatlanders, are shapes like circles, squares, and triangles. They can move left and right, forward and backward, but the concept of up and down is entirely foreign to them. For a Flatlander, everything is experienced in 2 dimensions. If you were to place a finger on their world, they would perceive it as a sudden, inexplicable shape appearing out of nowhere. They have no awareness of the third dimension, just as we might lack awareness of dimensions beyond our own. I like where this is going. Imagine a new direction. Now consider how we, as three-dimensional beings, can comprehend the idea of a fourth spatial dimension. It's challenging because all our experiences are confined to length, width, and height. But just as a flatlander might struggle to imagine up and down, we can attempt to stretch our minds to envision a direction perpendicular to all three of our known dimensions. Oh gosh, okay, this is what I'm talking about. Think of it like this. If you were to draw a dot on a piece of paper and then draw a line extending from it, you've added a dimension, moving from 0 dimensions, the dot, to 1 dimension, the line, and another perpendicular to the first, and you've created a 2-dimensional plane. Introduce a line perpendicular to both of those, and you have a 3-dimensional space. Now imagine adding yet another line perpendicular to all 3 existing ones. This is where the concept becomes abstract because we can't physically visualize it, but mathematically it can be described. Perception limits. This is so good, right? And I just say, one of the main reasons I really wanted to do this is, I've told you guys that I really, really want to look into the dimensions of the universe. And that's like my scientific deep dive of my life. And so I didn't know, it was so crazy how this all came about because I had this book for a while. I've been thinking I need to delve into this dimension thing, but I need like an entry point, you know what I mean? That I can do. Then literally the day before I started doing this, I was looking at this book because I've got it here in my stack of like my notebooks and like my things all the various books that I use frequently. And I was like, oh my gosh, what if I do this as a series on YouTube and I can bring you guys along the journey? And also I've never heard of the bubble theory. So this is for me just fascinating and I love learning. Like my brain feels so switched on at this moment. Our senses are so it says perception limits. This is the next section. We're in chapter 1 still. Our senses are tailored to perceive the 3 dimensions necessary for survival. Our eyes capture light that reflects off objects in our movement, allowing us to judge distance, depth, and movement within 3-dimensional space. However, we can't directly perceive anything beyond these dimensions, just as a colorblind person might not experience certain hues, or a person can't hear frequencies beyond their auditory range. We may be blind to aspects of reality existing in higher dimensions. So that's perception limits, the limits of our perception. I think that's such an important concept to just think about, like in life as people, that we are as humans, and I think any reasonable or smart, any good scientist, let's put it like that, has to be just as aware of your limitations as the things that you know. And I think this is very important, that just because you can't perceive something, just because you can't see it or you haven't experienced it, and that just goes in life. Just because you haven't seen something or haven't experienced it, that doesn't mean that it's not real. And so that's what's so interesting about delving into different scientific subjects, I feel like, because anything is kind of possible in a kind of way. You know what I'm saying? And henceforth why people bring up all these theories, and then scientists work on the various theories to see what theories make sense, what theories don't make sense, what evidence is there in the things that we do understand, whilst also recognizing that we may not fully understand, As I've said to you guys before about my favorite scientist, Gregor Mendel, who technically was a mathematician who discovered, genetics through peas, like literally peas, by breeding them together. And he realized, it's not just that we have only you as a child come out as 50-50 of your parents. Actually, we've got dominant or recessive alleles in the DNA. So if brown eyes is dominant, then it's likely that all my children are going to have brown eyes, etc., etc., as opposed to just what people thought before. But again, he was a mathematician. So the way he wrote his work, people didn't get it because they were like, what are you talking about, brother? Like, brother, what is all these numbers? They didn't understand that he had made like a huge biological discovery as to how our DNA was operating in terms of, having children and stuff. And it was only after he died that people recognized his work. So I think I love that whole concept, and considering your limitations and our limitations as people. Because as I've said to you guys before, that understanding that something might not make sense to you is fine, but believing that something isn't possible just because it doesn't make sense to you is a problem, I feel. I have said this before. Shadows and projections. One way to approach understanding higher dimensions is by examining how higher dimensional objects cast shadows in lower dimensions. For instance, a 3-dimensional object like a ball casts a 2-dimensional shadow on a wall. The shadow changes shape depending on the angle of light, but it can never fully represent the ball's three-dimensional form. Similarly, a four-dimensional object would cast a three-dimensional shadow in our world. Oh, this is getting interesting. This projection might seem bizarre or impossible to interpret because we are missing the full picture. The Tesseract, a glimpse into the fourth dimension. A common example used to visualize the fourth dimension is the Tesseract. Okay, I'm going to have to go and look up what this thing is. Hold on. Oh, this is so interesting. Okay, I'm going to let him explain it. I needed an image that I could like visualize, right? If I was one of them YouTubers, I would put something on the screen, but we all know that's not going to happen. Right. You go and do your homework. You go and buy the book and you do your homework as well, okay? This is what we do. This is how you be a lifelong learner, okay? Anyway, a common example used to visualize the fourth dimension is the tesseract or hypercube. Just as a cube is a three-dimensional extension of a square, a tesseract is a four-dimensional extension of a cube. Point 0D, no dimensions, 2 points connected, expanding in one dimension. Square, line, 1D, square, 2D, 4 lines connected, extending in 2 dimensions. Cube, 3D, 6 squares connected, extending in 3 dimensions. Tesseract, 8 cubes connected, extending in 4 dimensions. Okay. Okay. When we attempt to represent a tesseract in 3 dimensions, we create a projection that appears as a cube within a cube. True. With lines connecting the corresponding vertices, it looks distorted because we're compressing a higher dimensional object into lower dimensional space, losing some of its properties in the process. That makes sense. And it goes again back to what he was saying earlier about your perception limits, as in, again, we have to be aware. And I guess maybe this is why I started the first chapter talking about us being in the third dimension. We're always looking at things. This is the perspective from which we come from, right? So interesting. He's going to talk string theory. I can't believe we're at string theory already. I love some string theory. You might wonder why we should bother thinking about dimensions beyond the 3 we experience. The answer lies in the pursuit of understanding the fundamental nature of the universe. In physics, higher dimensions are not just abstract concepts, but potential explanations for complex phenomena. String theory. You guys don't know. This is how you know me and my brothers are nerds, right? Because we have talked at length about string theory. This is the stuff we talk about. String theory proposes that additional dimensions exist but are compacted or curled up at scales too small for us to detect. So exist but are compacted or curled up at scales too small for us to detect. These extra dimensions could unify the forces of nature or explain the behavior of fundamental particles. Unified theories. Sorry, I have to take moments to process everything. Unified theories. Higher dimensions might provide the framework. Actually, I should also start writing questions because he said it anyway. Unified theories. Higher dimensions might provide the framework necessary to reconcile general relativity with quantum mechanics. Oh, I love quantum. You guys know that I love quantum. My 2 favorite areas of science, right? Anything to do with jet engines and nuclear weapons, okay? Jet engines, nuclear weapons, then quantum, because I love quantum. Shout out to Dr. John Tandy, my project supervisor. An invitation to imagine. While we may not be able to perceive higher dimensions directly, we can use mathematics analogies and imagine. Actually, hold on a minute. Okay. Who was I talking about general relativity with literally yesterday? Anyway, while we may not be able to perceive let me go back. So this next section here, an invitation to imagine. While we may not be able to perceive higher dimensions directly, we can use mathematics analogies and imagination to explore their possibilities. Just as flatlanders might theorize about a third dimension, we can speculate about the fourth and beyond. As we journey further into this book, we'll delve into how these higher dimensions might interact with our own, potentially revealing new insights into mysteries of the universe. We'll explore the bubble theory, which suggests, here we go, now we know what this thing is about to be about, that our reality might just be one of many coexisting in a higher dimensional space. You know what? Okay, right? So let's keep our minds open and our imaginations active. That's very much where we're at right now. As we step into the realms beyond the familiar, after all, every great discovery begins with the willingness to see beyond the obvious. And that's so true. Like, the thing about scientists is, to be a scientist, there's an element of arrogance you have to have in like being prepared to like just do the crazy thing and like just believe in what other people doesn't make sense to other people. And I feel like that's just a lesson in life again, like to people who come up with this stuff and these theories and all this stuff, you have to be willing to push yourself outside of your comfort zone and outside of the comfort zone of others and what other people believe sometimes to truly find something new. And that's why when people make these big scientific discoveries, it's often like he was talking about the contraction or expansion or static nature of the universe. That was a conversation that happened around the times of even Einstein, as I was saying to you guys before we discussed that but prior, when everybody thought that the universe was static, anybody considering the concept that the universe could be expanding or contracting, whichever it would be, which eventually we've now discovered it's expanding, was insane. So for you to actually be the person to decide to embark on the journey of seeing if that's possible, for me, that's the fun of science, because you're always experimenting and you don't necessarily know where things are always going to go, but you can look at the data, you can do some tests and see where you find yourself. So I think this is so cool. And I've never heard of anything close to the bubble theory, so I'm I've heard of some other theories. I've not heard of the bubble theory before, so I'm really interested by this. And finally, he summarized the key takeaways from chapter 1. I love these summary bits. This is good. This is a good task to do in life. You should, anytime you understand something properly, you should be able to, I'm saying this is me putting my teacher hat on, you should be able to summarize it, you know? So like, even when you write like scientific research papers, you have to have like an abstract at the front of your paper. And the abstract is like the bit that people can see. Like if you go search even online, if you can find scientific papers, you'll see the abstract and you can see like essentially everything you've done should be summarized into a paragraph, because first of all, if you understand it properly, you should be able to do that as the writer, but also for the reader to get them to have an understanding. So this is an important skill. I love this here. So number 1, dimensions defined. Dimensions are directions in which movement or measurement is possible. Length, width, and height define our 3-dimensional space. I'll be curious to know what the 4th measurement would be. Like what length, width, height, and then what's next to the 4th dimension. I'm curious to know if we're going to find that out. Flatland analogy. Imagining a 2-dimensional world helps us conceptualize how higher dimensions might exist beyond our perception. And that's just a perfect way to describe it. I feel like showing the idea that if you're to 2-dimensional people who are, you know, left and right, forward and back, not up and down, experiencing that, something that's coming in that operates in the up and down, like the way he explained it anyways, is perfect. So that's something we have to think, that our experience, again, this is why we do have to be open-minded. Although, as you guys know, I feel that the education system tries to stop us from thinking critically and open-mindedly. But anyway, visualizing higher dimensions. Tools like projections and analogies allow us to consider 4-dimensional objects even if we can't perceive them directly. That's what I think is... this is what I like about, you know, science and scientists and maths and imagination and the brain and everything. And why we're so powerful as humans is that sometimes you may not be able to fully understand something, but we can kind of find ways to explain them, of which there's been plenty of good ones here. Relevance to physics. Higher dimensions are integral to theories attempting to explain fundamental aspects of the universe, such as string theory. And finally, embracing imagination. Considering higher dimensions requires us to think creatively and step beyond the limits of our senses. So for us to be able to understand anything, we got to, sorry, I've already cheated and looked at the title of the next chapter. So yeah, we have to be prepared to like kind of go the step forward to say, well, what's this about exactly? You know what I'm saying? You know, and be open-minded to what, just open-minded, full stop. Like not open-minded to one thing or another thing, but open-minded to whatever you see before you. And that's the fun of science, you guys. So this is so much fun. Also, special shout out to Jamil Chamberlain for letting me make this series on his book. Go buy the book in the description box below. If this is the first of all the videos you've watched, I've got 2 videos prior to this one, and all the videos will be linked in every single video. I'll link both the book itself that you can get for yourself. Super cheap. I highly recommend to add it to your repertoire, to your book. I'm one of those people who's been trying to develop the books I want to have on my bookshelf. You know what I mean? Like, what are the books I want to have on my bookshelf in my, you know what I mean? And the whole series as well are going to be linked in the description box below. I hope you guys are enjoying this. We're doing a bit of science together. I think it's a lot of fun. So yeah, guys, I'll see you in the next chapter. We're going to be in chapter 2, which is the 4th dimension, a new frontier. So I'm very, very interested and curious to get into this. Oh, this is so much fun. In a way, I could easily sit here and record through the whole book, I feel, in one day, but I don't want to do that. I want to like let the things stew. It's a lot of information and I want to let us all process. So I'm going to not post everything. I'm not going to do that. I'm going to just try and do maybe 1 or 2 chapters a day. Other than that, you guys, you already know what I'm about to say. If life's a game, let's play to win. Let's play to win, everybody. God bless you. God loves you. I love you. And I'll see you in my next one.